Hello everyone, I welcome you all to the lecture series on thermodynamics. Today I will introduce some basic concept on thermodynamics. What is thermodynamics? Thermodynamics is a science which deals with the relations among heat, work and properties of system which are in equilibrium. Right? It describes state and changes in state of physical system. So here equilibrium means thermodynamic equilibrium. Thermodynamic equilibrium means system should have thermal equilibrium, mechanical equilibrium and chemical equilibrium. So what is the thermal equilibrium? Thermal equilibrium means the temperature of the system does not change with time, right? For example, here if we see temperature within the system, right? Here some gas is there. Here inside this closed system gas is there, right? So temperature inside everywhere, right, within this system is constant. It is a 40 degree centigrade. So this system we will say that it is the thermal equilibrium. Second is mechanical equilibrium. Mechanical equilibrium means there are no unbalanced forces within the system or between the system and surrounding, right? For example, here this is the piston cylinder arrangement. Here this this piston is moving, right? Means this boundary is moving. It may move in upward and downward direction, right? So here, but here external force is F, right? When it is mechanical equilibrium, in this case P equals to means pressure inside this gas. Here inside, here it's a gas. Pressure of this gas P equals to F upon A. So this is, so this system we will say this is the mechanical equilibrium, right? Because there is no external unbalanced force, right? Similarly, if system is closed, right, here it is closed, means there is no moving boundary, right? So here if we see pressure everywhere, it is a 200 kilopascal, means it's a constant, means there is a no unbalanced force within the system, right? Here it's a this is a closed system, so here within this system there is no driving force or unbalanced force, right? Third one is the chemical equilibrium. Chemical equilibrium means no chemical reaction take place in the system, right? If any system is there, right, here mixture of gases is there are gases, right, mixture of gases, right, but these gases are not reacting, means their chemical composition does not change with time, right, and throughout same throughout the system, right? So this is called chemical equilibrium, right? System, but what is system? System means system, how we will define the system? System means the quantity of matter or a region in a space, right, where analysis is done, right, or that region is selected for the analysis or for study, right? For example, here this is the piston cylinder. here inside there is gas, right? So this is called system, because we are interested to study what is the properties and how much heat is coming and work done on the system, like that, right? So this is the we want to do some study. So this is the, for us, this is the system. Here this is a system, right? So similarly, in a line diagram, here we can show this one. This is the system, right? And this system, rest of this system, other things, this is called surroundings, right? All other things except the system, these are called surrounding, right? So region or surrounding is a region outside the system is called surrounding, right? And the system separated by the surrounding, that region is called boundaries, right? This is called boundary. For here, this is the boundary, right? Here this is our boundary, but this system and surrounding, it's called universe, right? So system and surrounding, it's called a universe, right? So different types of closed system. Closed system means when there is a no mass interaction between system and surrounding, only energy may interact, right? For example, here we have a closed system, means it is a container, right? Inside this container, gas is there, right? Here it's gas is there, right? So but there is no leakage, right? There is no path to escape this gas from the surrounding, right? And no gas may come from surrounding to the system. So such system is called closed system, right? But here energy may transfer, right? For example, heat, we can give the heat to this system. Heat may go into the system or come out from the system also, right? So energy may interact with the system, but no mass interaction between the system and surrounding. Such system are called closed system, right? So here it's a fixed boundary, but here in a closed system, here movable boundary also. For example, piston cylinder arrangement is there, right? So here this is also closed system, right? This is also closed system. Here we can means heat may interact, go into the system and work. We can get some work also, and also there will some change its properties, right? So this system is also an example of closed system. Second one is a open system. Open system means both energy and mass may interact between system and surrounding, right? And third one is the isolated system. Isolated system means there is no interaction of mass and energy with the system, right? So for example, here if we see, these are the diagram, closed system. Here closed system, in a closed system, heat may interact, heat and work, right? Means energy may interact with system, but no mass interaction, right? No mass interaction, there is no mass flow, right? This is dot is flow, there is no mass flow rate between system and surrounding, right? So but here this is a closed, so means constant mass within the system. Here mass is constant, right? In open system, here work and heat both may interact, and also mass will also interact with the surrounding. Here mass coming in, this is mass coming in into the system, and here mass going out from the system, right? So here in the closed system mass is constant. Here mass may be constant or may not be constant also. If there is a different flow rate, here mass, here inlet is higher and outlet is lower, so definitely it's inside this is mass is not conserved. But in a closed system mass is constant, right? But here mass may be or may not be constant within the this system, right? And isolated system, here no energy or mass interaction between system and surrounding. Such system is called isolated system, right? So here the closed system, here example is piston cylinder here, and inside definitely here it is some gases within this system, right? So here this is the example of closed system. Here it is a open system, turbine, right? This is the symbol of turbine, right? Turbine, here gas is expanding, so this is the reason here we use this symbol for the turbine, because here gas is expanding, right? And in a compressor, here in a compressor we use this symbol for compressor, right? So here mass interaction means in a turbine mass will high mass rate of steam will come, right? In case of steam turbine, so it will produce some work and then it will exit from there, right? So here it will, the work in turbine case we will get some work, that is in positive, because work done by the system. Here this is the system, so this system is doing work, so we will get positive work. But here we need, in a case of compressor, we need to drive the compressor, so we need some energy. So work done on the system, this is taken as a negative, right? So the work done, so compressor is a work consuming device. So mass coming in here and going out or leaving out from this compressor, right?